Alright, this is the second video for section 7.3 on complex numbers. And so just as a quick review, a complex number is of the form a plus bi, where a is the real part of the complex number and bi is the imaginary part. Just as a little review, the square root of -1 is equal to I. So let's not forget that. I've written some examples of complex numbers up on the board. The first one shouldn't surprise you, 3 minus 2i. The number 4 is actually a complex number because the b value is simply 0. All right. Also, 7i is a complex number and the a value is 0. So all of these that I had up originally on here are examples of complex numbers. All right. So here we go. We're going to move on and talk about something called complex conjugates. Okay. And so here's the definition of a complex conjugate. If a plus bi is my complex number, then its conjugate is a minus bi. That seems really, really easy, doesn't it? Okay, so the deal is that whatever sign is between the a and the bi, when we change it to the opposite, that becomes the complex conjugate. So you're wondering, what is the significance of this complex conjugate? Well, let's see what happens when we multiply a complex number by its conjugate. So let's look at 2 plus 3i is our complex number. The conjugate would be 2 minus 3i, and when we multiply these two binomials together, two complex numbers together, here's the first, here's the outside, here's the inside, and here's the last. Okay, so what we notice right away is that the outside and the inside cancel each other out, and so we get this. Okay, and so we need to recall that I squared is another name for -1. And if you forget why that is, remember that I is the square root of -1. So when we square that, we get -1. Okay, so important to notice. And so this really becomes 4 plus 9 or 13. So the significance of a complex conjugate is that if you multiply a complex number by its conjugate, the I disappears. Okay? So why is that important? Well, because when we talk about fractions, so we're going to talk about rational numbers now, where I is in the denominator, we are not allowed to leave I in the denominator. So for instance, here's my example. Let's say I do a problem and I'm done and I get the answer 7 over 3 plus I. Rule is, math rule, we have them all the time, no I in the denominator. So we want to make the I go out of the denominator. We don't care about the numerator, it just can't be in the denominator. So what we're going to do is we're going to multiply this fraction by the conjugate, all right? And because we don't want to change the value of the fraction just the way it looks, we end up multiplying by a version of 1. So we take the conjugate of the denominator and multiply by that as a fraction over itself, all right? And so on the top, it's the simple distributive property. And in the bottom, when we do first outside, inside, last, we end up getting 10. I did that really quickly. You can check my work. All right? So that is the significance of a complex conjugate. All right? We'll have a lot of time to practice that in class. Sometimes in the denominator, there's an imaginary number, but there is no real part. So for instance, if I have 15 over 4i, I do not need to multiply by the conjugate unless the denominator has a real and an imaginary part. So I've actually done the more complicated problem first, and now I'm moving to the easier problem. So to get the I out of the denominator here, we simply multiply by I over I. All right? So what we get on the top is 15i, and on the bottom we get 4i squared. And I squared is -1, so we get this, and we always, when we simplify a fraction, we don't like to leave that negative in the denominator. Okay, so that would be our solution. All right, let's do one more, and then we'll be done. And then tomorrow in class we'll practice a lot of this. What about if we do have a complex number in the top with I and in the bottom? Not a complex number, just an imaginary part. Sorry, it is a complex number, but no real part. So we're going to multiply the top and the bottom by I, right? I over I. What we get is 10I minus 15I squared all over 5I squared. So we never leave I squared in an answer, and we get 10I plus 15, right? Because this is negative and that's negative, all over negative 5. And so then what we're going to do is we're going to simplify by dividing through by a negative 5, and we get negative 2I minus 3. And if that bothers you because our complex number is always in the form a plus bi, you could also write this negative 3 minus 2I. Either of those answers is acceptable. Okay, there you have it, complex conjugates and getting I out of the denominator. See you in class.